Hi friends, so recently I cleared Power BI APN 300. Then after that I was exploring what's next to learn, which tool we learn, which subject or which concepts we can learn. So in that moment I had a thought whether I can learn Fabric next, but I also had a doubt, just for the sake of certification do we need to learn Fabric like that. Then I glanced through the topics of Fabric. Then I found out that most of the topics, not most but some topics were overlapping topics which I learned for Power BI, and some topics were the extension of the topics which I learned in Power BI. So I decided that in this heat of the moment itself we will learn I will learn the Fabric and for the certification DP-600. I decided, I made the decision, and this is the first video in this Fabric series. I and in upcoming days I'm going to post my share my learnings about Fabric. Without further ado, we will get into the presentation. So this is the topic for our today's session, discovering data in OneLake Microsoft Fabric. So why Fabric? Before learning about Fabric, we need to understand why Fabric is used and what problem it solves, what existing problem it solves, that we need to understand before moving to Fabric. So in traditional systems, if we see the data are stored in separate silos, uh, and the communication between different data source systems is done manual, and there were in data inconsistencies, and data needs to be converted into the suitable data format for different data source systems. But here in Fabric, it provides a platform. It is basically a SaaS platform where data is stored in a single format called the Delta Parquet format in a storage layer called OneLake. If you see here, that's what in this picture denotes different data source systems, and basically before Fabric, every team different tools duplicate data. And then after Fabric, all the different systems, all the different teams comes under this particular platform. So where is our data? Earlier, in traditional methods, data is stored by one team, and for analysis, data is stored by another team in separate system. For data engineering, data is stored by separate team. And to find the right data, the team needs to communicate and work together, and they need to align together. This method, there is a prone to error, and there is a delay in finding the right data. So this particular problem solved by the storage layer called OneLake inside Fabric. So what OneLake is doing? OneLake helps us to find the right data. It is basically storage layer of the Fabric. When Fabric is enabled, this OneLake will comes into the picture. So think of OneLake as a big lake of water. Inside a lake, multiple animals, fishes will be there. Similarly, different types of data flows into the OneLake, and the and only one copy of data is maintained across the system. There are no duplication of data. When change occurs in the data, uh, uh, in one data source system, and the data used by other data source system will see the update, and the different team will know about a change made by different team under one ecosystem. So this is what OneLake does, and this is what Fabric provides. And also the point to note here is the Fabric cannot be enabled by an individual. It needs to be implemented by the organization. So the decision needs to be made by an organization, the whole organization. So as we have just now we have seen that the OneLake holds all kinds of data. But how can we find the right piece of data? That's where OneLake catalog comes. It acts like a search engine, but exclusively for one's own company. We can search data by name, by team, by workspace, and etc. And once the when we search for the data, we can get the details or properties like owning user, when was the last changed, and etc. So for finding the good data without asking around and without much effort, this helps us. One like a catalog helps us. Now, how can we trust the data? We searched for a data, but we need to validate or we need to confirm whether this data is trustworthy or not. Not all data are equal. Some data are ready to use, and some data are not checked yet. So we need some kind of endorsement uh, for that purpose. Microsoft Fabric gives these three endorsement labels: promoted, certified, and master data. Promoted can be done by any user uh, who has right access for their data, and for the data which they think they can share, they can use this promoted label. Next comes the certified. Uh, for To do this labeling, not only one should have a right access for their data, they should be approved reviewer by an admin tenant. Only if they are an approved reviewer, they can give a certified label for their own data. Then comes the top label, which is the master data. Master data can be provided to a data which acts as a single source of truth, like companies' product codes and companies' customers and etc. For top information, for very important information only, this master data is provided. So these endorsement labels helps us to pick the right data and which data to trust. So now we can see what kind of data we can find inside OneLake. There are basically four kinds of data we can find inside OneLake. First one is tables, which can live inside a lake house, event house, or warehouse. What are the basic differences between these three systems? We can see in further upcoming sessions. Second thing is files. Files of any format like Parquet, CSV, JSON can be found inside this OneLake. Third one is shortcuts. Shortcuts are nothing but references which points to a data located in a different location. Without copying it, it just stores the references. Last one is semantic models, which we know this is the basic data model foundation for creating a reports. All the four kinds of data show up in the same catalog. Next, now uh, we need to choose the ingestion methods, and based on that we can know how data gets into the OneLake. First method is mirroring. Here the live data is copied from data sources like SQL Server or Snowflake, and the data is kept updated inside Fabric. Second one is pipelines. The data is pulled and moved and transformed through data factory through pipelines. What is a data factory? We can see in further upcoming sessions. Third one is data flows. Data flows are nothing but a Power Query online. The users who are using Excel or Power BI and who knows Power Query, the data flow is similar to that only, but it is present inside Power BI service. And next one is streaming. The streaming is mainly used for real-time event data, like website events, website clicks, or IoT sensor data. Similar to this data, this method is used. And last one is direct upload, where data is directly uploaded into the fabric itself. So we need to pick the best method based on where the data sits. Okay, now we talk about connecting the data without copying. That's where the shortcuts come. This is the term which I learned newly when learning Fabric. Shortcuts. What shortcut does? Shortcut is used to create a reference where that reference points to the location where data is stored originally, but the shortcut is created in a location where it does not copy the data from the original location. And this shortcuts works across teams and workspaces. These shortcuts are perfectly suitable for a layered setup. For example, from raw data to clean data to create a curated data without copying anything. All the changes can travel from one end to other if we create shortcuts. How shortcuts are created, I will show you now. So here I have already created a shortcut. This is in Analytics Lakehouse. How to create a shortcut? In the ellipsis icon, click this one, new table shortcut. So the table is located in different lakehouse, and I created a shortcut in this particular lakehouse. Which lakehouse this is created? We can see that. Like here, if you see, it is showing like sales data. This is target data where original data is located, sales data lakehouse, and this shortcut points to that info. If I click this icon, you can see that Microsoft OneLake is there. By clicking this one and then just selecting this lakehouse, we can point to the particular table. And there are some external resources also there. We can connect to data located in different data sources also. So that's it about shortcuts. Okay. Just now we have seen about the shortcuts, but before connecting with the shortcut, how can we know whether the data is right or suitable or can satisfy our requirements? For that, this SQL Analytics endpoint option is used. Every lakehouse has this option. With this option, we can query the data available in a particular lakehouse. We can check and confirm before building anything on top of that data. And also, it is to be noted that a Copilot option is there, which helps us to write SQL queries. But this is available only in Fabric paid version. In trial version, this is not available. Here, if you see, currently I am in Lake House, which is sales data Lake House. I'm switching it to SQL Analytics endpoint. So I'm creating a new query. I already have a query pasted in my clipboard. Now, if I run, yeah, you can see the queried data. Similarly, you can try and run as many queries based on your requirements. And then after verification is done, you can connect with the table using shortcut. So whomsoever having a knowledge about Power BI knows that the semantic models are the basic foundation for creating reports. The semantic models already have relationships, calculations, and business logic rules built within them. With the semantic models available inside the fabric, we can use these options like explore the data option, auto create a report option, and analyze in Excel option. This option is similar to the option available in Power BI service, where we will use analyze in Excel in report, right? That is this option. So these two options are these options are useful. Before creating a final polished report, we can explore the semantic model by creating instant visuals and by creating instant tables. Okay, now we can see how these options are put into practice. Okay, now this is the data engineering workspace. Now this is the semantic model already created. First I am selecting export this data option. So here you can, I am just including some info, random info, like yeah. Here you can see that visuals also there and matrix also there. We can slice and dice the data and we can know about the semantic model. You can select a suitable visuals and also you can create a visual calculations which you can find in Power BI also, where you can create a visual calculation with respect to specific visual, right? Same thing is here. So likewise we can explore the semantic model with this option. Not saving. Then another option is auto create a report. This option creates helps us to create the report automatically, where instant report is created. It is not a polished one, but it gives quick overview about the data. So before digging deep into the semantic model, it gives the quick overview, and based on this, you can build your finalized report on top of it, and this can be used for verification purpose also. If some value you are getting it is wrong, and if it is getting contradicted with the value which it auto created, you can use this for verification. So this is how the semantic models are built in Fabric. So now if we see, earlier I told Copilot is integrated with Fabric, but in order to get good insight or clean insight from Copilot about the organization data which is present inside the Fabric platform, the names and descriptions should be proper. Data needs to be sanitized properly. If the data is unsanitized, then the info or insight which we receive from Copilot, it will not be proper. Now, till now we have seen about the data which is at idle in OneLake catalog. Now, if we see some data, those data flows continuously and they never stop moving. For example, the stock level change as items are sell, or sensor reading of IoT sensors monitored every second. These kind of data flows continuously. So to monitor that, to maintain that, different type of catalog is used, that is called a real-time hub in Microsoft Fabric. It shows event streams, event houses, and stores data in KQL databases. Here if you see, KQL is sounding similar to SQL. Mostly SQL is familiar for us. SQL is used for querying against the different data source systems, relational database and data warehouses. Mostly transactional data will be stored here. But when it comes to time-based data or a real-time data, Microsoft created this specific language to query against the data source systems storing or capturing the real-time data. So this specific language is created, and the tables related to that specific language are created for capturing that real-time data. So in short, if we if we want to say, one lake catalog captures the data which is in idle or at rest, but real-time hub captures the data which is in motion. To see high-level overview of how real-time hub looks, we can switch to Fabric. I can show you there. So this is the way of real-time hub. You can see that, like, you can select the real streaming data option and you can add data. This is the initial view, and now the add data tab. If you can see many data source systems are there, from which you can connect and connect to different streams to get the data. So in order to explore, Fabric already provided this three data source systems which you can connect, and you can create the components related to the real-time hub. I already created some components related to the real-time data. Uh, if you see here, yeah. So when you connect, you can select what are the components needed. I selected all the components. You can see activator, different components called activator, event house, database, event stream. These things you can select when connecting with the stream. So from here you can see activator. So basically we just see high level overview. For digging in depth in upcoming sessions we will see. So what is an activator? Okay, so here I already opened. Activator is nothing but low code or no code automation, where you can set the rules, and rules like notification needs to be sent when particular threshold is hit, or we need to start a, Python job or Spark job. These kind of automations you can do here. And if I set a new rule here, already set. So if I set a new rule here, on every value, these kind of things, and action you can set here. See, run a copy job data flow. So these kind of automations you can do in activator. Now next option comes event house. Event house is a storage layer, which in this session itself I will explain. And KQL database, I will show you the KQL database. KQL database is the data where it is connected with the data source system, and continuously that real-time data flows into the database. Here the schema is created, ingestion is done and schema is created in this database. You can see here the tables, and if you check, if you click this table, you can see that table is loading and it will appear. The schema is created, but in real time lot of transformations and cleaning needs to be done before creating this database. Now for exam, for this sample scenario, it got created easily, but in real time lot of cleaning and validation needs to be done. Next comes the event stream that I will explain in this session itself. Query set is similar to SQL analytics point, which we have seen in OneLake catalog. This is the KQL language which is easily readable. Just now I also started reading it. Is self-explainable only. In further sessions, I will explain in depth. So these are the sample KQL statements from through which we can query against the KQL database. So next thing is semantic, but semantic model, it's just a Power BI semantic model which got created based on the source system, and this Power BI report real-time dashboard. This dashboard is similar to uh, this one only. Yeah, here is the dashboard. The dashboard is similar to the dashboard which we create in report, right? See, our live data, it is getting updated, right? So it shows the line graph, and to monitor the important info it is used, and these graphs are auto generated. Now the Fabric generated it automatically. So to monitor and capture the important and critical info, this dashboard we can use. So these are the basic overview of real-time hub. Uh, in upcoming sessions, we can see and in depth of each component and what component needs to be selected and different scenarios, how they function together. So these things we will see in further upcoming sessions. So next we will see the two major components of real-time hub. There are many components which I told earlier, but these two are the major components of real-time hub, which I want to highlight it specifically. Event streams and event houses. So event streams are the ingestion engine in real-time hub, where it connects the source system with the destination inside Fabric. In between, many transformations and many filters are created where the data is shaped and then it is pushed into the destination. Mostly the destination will be event houses where these event houses act as containers for holding the KQL databases. Uh, it helps to monitor the health of the KQL databases and helps to monitor the ingestion rates and how the streaming pipelines are working, whether it is proper or not. So these are the basic definition for event streams and event houses. How it looks inside the Fabric, we will see in the Fabric itself. So here is the event stream created automatically when connected with the source system. So this component is auto created. Here you can see the flow diagram is simple, like this is a source and this event stream created, and this is the destination. This destination is, you can see, this is the event house, right? Then for transformations you can add, these are the various operations, okay? uh, Filter, aggregate, group A, many operations are there. For each and every operations, the flow diagram will get expanded and it can be modified according to the operations which we add. So this high level diagram will help us to understand how data flows from one end to the other end. Next, to event houses, right? So when data is received through event stream from the source, under the event house there are many SQL database, KQL databases will be there. Sorry. So the KQL database stores the data under event houses, which act as a container for them. It helps us to monitor the KQL databases compute resources. That, for example, like this event host storage resources. So the metrics of the compute resources are monitored here. This ingestion rate. So this kind of info is monitored here, and here we can see what are the databases currently connected. Currently only one database is connected. You can connect multiple databases under one event house. Yeah, so this is the basic overview of event house. Okay, now if you see, when you find a stream or data source, you have a variety of options to uh, do based on the requirements. Okay, first thing is event stream. You can just set alerts with Fabric activator, which we have seen just now, or you can just create a shortcut. Or the next option is, with that event stream, you can connect that with event house. Under that event house, KQL database will be created, and you can query against that KQL database tables to build dashboards and set alerts under results, and you can then generate insights from that. Or third option is you can combine the streaming data, real-time data, with the batch data, which we have seen in OneLake catalog, right? Under one report, and then you can generate a combined insights from that. Next one we can see is we can connect multiple resources, data sources with the fabric. In this session, we have just seen high level and some sources I have shown, but in real time, Fabric has many options or many connectors to connect with variety of data sources like Microsoft sources like Event Hubs, IoT Hub, Database CTC, Azure Events, external sources. Only some sources I have mentioned. In addition to it, many sources are there. So this is the crux which we have seen in today's session. First thing is to discover data. For ideal data, OneLake catalog is used, and for real-time data, real-time hub is used. Then comes the connection. For connecting the data with the data sources, or establishing connection between different data sources inside Fabric, shortcuts are primarily used because the goal is to avoid duplication, right? So shortcuts plays major role in establishing connection. Next come analyze. Fabric provides variety of options to analyze the data, like the semantic models. We can create a semantic models, and then we can explore the semantic models using explore option and create auto report option. Or on top of semantic models, you can manually create a report, then you can start exploring. And also using KQL language, you can query against the KQL database. You can create a real-time dashboard, then from that you can generate insights. So like that, many options are there to analyze the data inside Fabric. So that's it for the today's session. Hope you have gained some info from my session. So if you have any feedbacks or questions, you can post it. Feedbacks are appreciated. Thank you.